So there was a question about whether it is possible to have an f of the following form, right? So does there exist an f such that f transpose f equals 0 tensor? In general, no, right? And there are at least a couple of ways to show this. One way to show this would be that we know what the effect of f transpose f is upon any vector, right? Okay, so the answer, in general, no. Okay, the reason is no, because f transpose f equals 0 would imply that now if you took any vector epsilon m dotted with f transpose f epsilon m, where epsilon belongs to positive real numbers and m belongs to R3. Furthermore, we know that the magnitude of m has to be 1, right? So if you took any vector and decomposed it into its magnitude and direction, having f transpose f equals 0 would imply that this square of the stretch of epsilon m was itself equal to 0, right? Identically, for any m, for any vector m, right? This would have to hold for all epsilon m, right? For all vectors epsilon m. So essentially, you have a deformation that takes any vector in any direction and reduces it to nothingness. Okay, this obviously violates the impenetrability of matter, the local impenetrability of matter. Okay, so what this implies physically is that any vector is shrunk to 0 magnitude by f. So on this prop, what it means is that you have an f that if you ask whether at any point in the body can f transpose f be equal to 0, no, it can't, because it means that at that point, for instance, if f transpose f equals 0 at this point, what it means is that at that point every single direction goes down to 0 under the deformation, right? You have a deformation there that is shrinking things there down to 0, which violates the local impenetrability of matter. Okay, so that's not allowed physically. It also can't be. It's also not allowed mathematically because what this also means. Also note that if you construct an f that's invertible, right? If you think you've constructed an f that's invertible, if f inverse exists, right? If there exists f inverse, right? You've said that you've constructed an f which gives us f transpose f equals 0. Then I say that, well, if f inverse for that particular f exists, it implies from the first line that f transpose, which is now the 0 tensor f inverse, itself equals 0, right? So this thing just gets violated in every possible way, right? So by contrary, it just doesn't work, okay? But it's a useful thing to think about.